Hi everyone. In previous lessons, we learned how to work with individual variables in Go. But sometimes we need to group together variables into arrays. In this installment of Programming for Lovers, we're going to introduce both arrays and slices in Go, and then we're going to explain how those two data structures differ. By the end of this lesson, we're going to be ready to conclude this chapter by implementing algorithms for finding prime numbers. As always, if you enjoy what you see, please like, subscribe, and join our course at programmingforlovers.com. Let's code. You'll see that to get started, I've created a directory called arrays within Go src, and I've created a folder in that directory called main.go and started to populate it with a little bit of code. So we're ready to talk about arrays. And you might wonder, what are arrays? And to define what an array is in Go, an array is a collection of variables grouped together under one variable name. But that array has to have a constant fixed size, and every variable in that array has to have the same type. These are important attributes that are going to become clear in a little bit. But what that means is that when we declare an array, we need to tell it precisely how many variables are going to go in that array, and we need to tell it the type of those variables too. So say I wanted to declare a variable called list containing 6 integers. Well, we're going to declare that variable in the same way that we declare variables normally. We're going to use the variable keyword var, and then we're going to have the name of our variable, which I said was list, and then to specify that it is an array of length, let's say 6, containing integers, I'm going to use brackets with 6 inside the brackets, and then the keyword int. So we've now declared our variable, and we can go ahead and let's use our variable by simply printing that variable list to the console. So I'm going to print list, because you might be wondering, well, what is it that list is going to contain? We're going to see 6 integers, and as you might guess, the 6 integers that we're going to see are going to be the 6 default values for integer variables. So we should see 6 zeros printed to the console. So when I save my file and then I cd into my src arrays directory and then compile and run, then we're going to see 6 zeros printed within brackets to indicate that they're part of the array. So if we have strings, then we'll have empty strings. If we have floats or integers, we'll have zeros. And in general, every variable that you declare in an array is going to receive whatever the default value is when you declare that variable normally. So the next thing that you might do would be to enter different values into the array that you created. So let's do that. And the first thing that we need to know is that, like many modern languages, Go uses zero-based indexing. So the indices of our array are going to range between, this array has 6 elements, so the indices of that array are going to range between 0 and 5 inclusively. 0, 1, 2, 3, 4, 5. So we'll have 6 values. And so if we want to access the first element of the array and set it equal to, say, -8, we would set list of 0 equal to -8 in the same way that we assign a value to a variable normally. If you've heard some squeaking and rumbling, it's my guinea pig office mates. So you might have had to have your volume up on loud for the past minute or so, but if you did, you probably heard some strange noises, and that's just them in the background, but they seem to be happy now. So returning to this, we have list of zeros equal to -8. And that's going to set the first element of the array. But we don't have to necessarily just give it an integer index. We could, for example, imagine that you could have another variable that's like I equal to 3. And you could set list of I equal to whatever you like, 17. Or it could even be an arithmetic expression involving I. So it could be 2 times I minus 4. So again, I'm bad at arithmetic. 2 times 3 minus 4 is 2. So that's setting list of 2, which is the third element of the list, equal to 17. And then in order to set the final element of the array, we would use list of 5 and say list of 5 is equal to 43. In general, though, we have a quick way of identifying what the final element of the list is. Note, we're going to have a length function that's built in that's going to tell us what the length of the list is. So if I were to say length of list, that's going to be 6. It's going to just go in and grab that length of the list, the number of elements that it contains. But remember I said that the indices of the array range between 0 and 5 inclusively, because if we go up to 6, that would imply that we have 7 elements. So if I were to set list of length of list, we might have an issue. And I'm going to show that here momentarily. But in general, if you want to set the final element of an array named list, you go and you access the index length of list minus 1. So we've done that. We've set 3 values. We set the first value, or the first variable's value, i.e. list of 0. We set list of 2 in a fancy way. And we set list of 5. So when we save that and compile and run, then we should see those values get entered into the associated parts of the array. So the first, third, and sixth elements have been set to the appropriate values, which is what we would hope. I promised that I would do this. So one other thing that I might imagine doing is setting something that's not in the range between 0 and the length of list minus 1. So if I tried to set length of list, the index of length of list equal to whatever you like, some integer 7, then when we compile, we're going to get an invalid argument here. Index 6 is out of bounds. So in other words, Go is telling us that the index that we tried to set, which is 6, is out of bounds for this array that ranges 0 up to, but not including 6. So it has 6 elements in it, and we're trying to set index 6 of that, which is simply not going to exist. The other thing that we might have an issue with is that some languages, I think Python notably, allows us to do things like this. Set list of -4. Maybe we're going to, for example, count backwards from the end of our list. So we could try to set this equal to 2. Go's not going to allow that. So it says I'm not going to allow negative indices as inputs to any array. Okay, so I'll just say these commands lead to compiler errors. So I'm going to comment them out. And that's the absolute basics of how to declare arrays and how to set their values. One thing that I might then do is let's involve arrays in a function. So the function that I want to write is, let's build off what we've been working on with factorials just to kind of get a feel for arrays and say, okay, let's imagine that rather than just computing, say, n factorial, let's compute all of the factorials up to n factorial. So technically, when we've been computing n factorial, we do that. We have a for loop that ranges from 1 to n, and we keep multiplying each integer by some value p. So along the way, we're actually computing all the factorials. And so we may as well store them in an array. So it's going to take as input our function factorial array an integer n. And it returns an array of length n plus 1. If you remember, from a previous code along, I taught you why 0 factorial is equal to 1. So we're going to have all of the factorials from 0 factorial up to n factorial, which means there's going to be n plus 1 of these values. So the array should have length n plus 1, where I should say whose kth element is k factorial. So let's imagine writing this function. So we're going to say we need our func keyword factorial array, and then we're going to give it the integer n that we want. And you might think, well, okay, I know how long my array needs to be. It needs to have length n plus 1. It's going to have integers. So if we follow this notation that we've used thus far, we would say the output type is going to be an integer array of length n plus 1. And you might imagine that if n is negative, well, we would say, let's panic. So we say there's a negative input given to this factorial array function. Okay. And if we make it here, then we know that we have at least a 0 value of n, which means that we're going to have some array of length at least 1. So we could declare that array that we want to return. I could say var fact n plus 1 int, and then eventually that's what we're going to return. So fact will store what we want, which is our factorials. So we could set, remember I said, recall, 0 factorial is equal to 1. So let's set our initial value of that array, and we can do that with just fact of 0 equals 1. And then we get to practice our for loops, and we say, well, let's range k from 1 to n, and use the fact that I'll have you remember another thing that I told you when we were working with a factorial function is that k factorial is equal to k times k minus 1 factorial. So you take the previous factorial, you multiply k by it, and you get the next factorial. So I'm going to use that fact to go in and access the preceding value of the array, because k minus 1 factorial is going to be stored in fact of k minus 1, and I'm going to simply multiply that value by k and store it in fact of k. So I need to think, well, I'm going to range k from 1 up to and including n, and I'm going to increase k by 1 each time. So there's our classic type of for loop. And each time I'm going to set fact of k equal to k times the previous value of the array, fact of k minus 1. And at the end, we will return fact. This looks great. I'm going to save it. And I'm going to compile. And I'm going to have two compiler errors. I'm going to have a compiler error here where I say n is undefined. Weird. And I'm going to have a compiler error on line 29 where it tells me that the array length n plus 1 must be constant. And both of those compiler errors are getting at the same fact, which is that you will recall that I told you every variable in an array has to have the same type. Okay, good. But I also told you that they have fixed constant size. So even though it makes sense intuitively to create an array of length n plus 1, that's a variable. It's an expression involving a variable. And so Go is not going to allow us to do that. The good news is that there's going to be an easy solution, but I wanted to show you this incorrect way of writing the function because I think that this type of notation is intuitive, and our solution is going to be pretty similar to this, but I want to use this as an opportunity to tell you we are going to use a solution that involves a slightly different data structure. It's not quite an array, and what we're going to use is called a slice. So for now, before I resolve that, so I don't get any compiler errors, I'm just going to comment out this factorial array function for now, and I'll come back to it. And I'm going to talk a little bit about what slices are. So in terms of practically speaking, a slice is really, you can think of it for now, as an array where you allow yourself to have variable length. I'm going to point out, even in this code along, how it is that arrays and slices differ, and then later on in the course, you're really going to appreciate the difference between arrays and slices and why they are the way that they are. But for now, I want you to be able to work with them, and so I just want to show you the basics of slices for now. So if I didn't know, for example, that I wanted exactly 6 elements, and I wanted to create an array of some variable length, or where the length is equal to some variable's value, then the way I would do that is with a slice declaration, and I'll say slice declarations are a little different. So I will declare a slice with the var keyword, with the name of the variable. Let's call our slice A. It's still going to contain integers, except I'm not going to tell it the length of the slice just yet. And if I wanted this thing to have length n, where say n is equal to 4, then I need a separate command which says, let's make, I will say slices must be made. And we're going to say a is equal to make the slice. remember the type of the slice is going to be bracket int, and then we can tell it n. So this is just a different way of thinking about how we're going to declare, for our intents and purposes, an array, but an array that can have variable length. And this will allow us to have, a slice is going to be able to have length that changes. So if we want to make it have length 5 or shorten it or something like that, we're going to be able to do that. So that just makes slices a bit more flexible than arrays. You also might wonder, I'm going to comment out these 2 lines before I do anything, and I'm going to print a, because you might wonder, what is the value of a? So when I save this and run, we're going to be able to see what is it that is the final thing that's printed. And you see these brackets get printed. So I'd say right now a has a special value called nil. And when you print it, you're not going to see anything printed. You just see the brackets printed because it doesn't have any length. It doesn't have any values in it. For now, though, I'll go back and say, okay, once we set n and make our slice, then for all intents and purposes, you're going to see something that looks a whole lot like an array. It's going to have 4 default values. So we know it has length 4, we know it has integers, and so they're going to have the default values of 0. And in the same way that you might imagine that we're going to set, in the same way that we have set values of arrays, we're going to set values of slices. So we set values of arrays similarly to slices. Those are slices. Okay. So if I wanted to, for example, set a of 0 equals 6, and a of 2 equals -33, and print a, then you'll see those values get set. That's the initial element of a, and the third element, which is at index 2. In the same way that we're not going to be able to set values of arrays at negative indices or past the length, the same thing is going to apply to slices as well. So one more thing I would say, in practice, we're going to use a one-line declaration. And so rather than have var a slice event, and I'll move this down, let's declare another slice b. And if I wanted it to have length n+2, I can use b : equal to make slice of int n+2. So it will have length 6. And then I can print b, and you're just going to see 6 zeros get printed. This is a one-line declaration. It is equivalent to var b slice int, var b bracket int, and then b equal make a bracket int n+2. You will very rarely have these 2-line declarations. So I would suggest just get comfortable declaring your slices in this way. But I wanted to show you both. Okay. So I can compile just to make sure everything's okay, and you see the 6 zeros in B get printed. We can come back then and fix our factorial array function, knowing what we know now about how to work with slices instead of arrays. So I can uncomment out my factorial array multi-line comment, and so that I can see the code again, or Go can at least. And now I can say, I see, rather than setting this equal to n+1 int, the type of what I want to return is a slice of integers. So just as when we return an integer, we want to specify that it's going to be an int type. Here, the type of a slice is bracket int. So that's the only change that I need to make here. And the only change that I need to make here is to make sure that I'm declaring my slice in the appropriate way. And I'm going to use the one-line declaration in order to do it. So I'm going to make a slice of ints of length n+1. And now when I compile, I don't get any compiler errors. And I could try this out if we want to check out our factorial array function. I could say, let's print factorial array of, remember it takes any integer we like, so we could give it 6, and we're going to print out a factorial array of length 7. So I'm going to compile, then I hit up until I get to /arrays, and I see what I would hope would be printed, which is the successive factorials. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial 6, then 24, 120, 720, and so on. So all looks to be in order with that function for now. And I will point out what is it that are actually the differences between arrays and slices. You're probably sitting there thinking they seem identical. Why is it that Go has two of these different sort of structures that you can work with? And I'm going to talk more about that, as I said, later. But for right now, I thought I would use it as an opportunity to point out a key difference that you should know. All right. And the way that I want to get at that is to say, I'm going to imagine two functions, and I'm going to write these functions quickly. Change first element array. It's going to take, let's make it have, I need to specify that it's an array. Let's have it have length 5 or 6. We've been working with that, 6. And it's going to return an array of length 6. So because 6 is a constant, we're okay here. Now this is going to be weird because it's only going to apply to arrays of length 6. But the only thing that I'm going to do is I am going to set a of 6 equal to 1. Okay. And I'm going to have the same sort of function. In fact, excuse me, I'm not even going to return anything. I'm going to have the same sort of function for a slice. Except it's going to take a slice of integers, which means it can take an array essentially of any length. And it's also going to set a of 0 equal to 1. I said the first element. What am I doing? A of 6 doesn't exist. Okay, a of 0 equal to 1 in each of those cases. I'm not going to return anything. I'm just going to set them. And let's go in here then and say, after we've called these, had these calls, let's do one more thing at the bottom of func main, which is, let's set, say, C, var C is an array of length 6. And so it's going to have the default values 0, 0, 0, 0, 0, 0. And let's also make D to be a slice of length 6. So even though this is a constant, it's okay. It's going to make it a slice. And then I want to call both of these functions. So I'm going to call change first element array on C. I got double parentheses there. And change first element slice on D. And then one more thing I'm going to do is print. We've got a lot of print statements. Print C and print D. So you might pause for a moment and just consider what you think might happen here, especially given what we have learned about what happens when you pass variables into functions. And I'm going to show you what happens, but I want you to hypothesize. In each of these cases, are we going to see different behavior? Are we going to see the same behavior? Is the value ever going to be 1 when we print it? Is it going to be 1 in both cases? Is it going to be 0 in both cases? What's going to happen? And I'll show you what happens. So if I save and compile and run, the last two things that are printed, and I could say C is now, just to make this clearer, because a lot of stuff is getting printed down there. And D is now. Okay, so each of these things started as having 6 zeros in them. We called the change first element function on each of them, but notice that C still has 6 zeros, whereas D has that initial 1. So these two functions, which have the same body, have very different behavior. You might be confused about one of them, because what I've taught you is earlier in code-alongs is that in Go, functions are passed by value. So when you pass something into a function, when you pass like an integer or a string into a function, you're used to what happens is that a copy of that string gets created as the parameter, and that parameter scope is the function, is the body of the function. And then at the end of that function, that copy is destroyed. And that's what we've learned about how, every type that we have seen in Go works. And in the case of arrays, that's what happens. You have your C array, you call change first element of C, and a copy of C gets created, and that's the copy that got edited. And then the copy is destroyed. So that's why So that's why you don't see anything changed here. But the case with slices is different. So when you pass in a slice to a function, you get access to that underlying array. So when you set this a of 0 equal to 1 and you passed in D, you get to access D and change D, even though you didn't return anything, from within this function. So how I would think about this for now is to think, well, arrays are passed by value, just like everything else that we've learned, whereas slices are passed by reference. The full understanding of that is a little bit more complicated than that statement. But for now, that's a great way of thinking about it. And then keep following the course, and you're going to have an even deeper understanding of what's going on. But we're not at the point that we can discuss that until we have a chance to talk about object-oriented programming and pointers and all sorts of fun stuff. For now, I think that's a good thing to think about. When you pass in a slice to a function, it's different from other variable types that we have worked with. You get access to the slice itself. It's not creating a copy of that data. I will often use the term array to mean slice. So I will use these terms interchangeably because I like to think on the level of pseudocode and bigger picture, sort of, what is the data really? When we're working with a slice, there is an array behind the scenes. It's a collection of variables that are all lumped together. So I may use the word array when I really mean slice. And the reason why is because the fact that an array in Go has to have this constant length means that we're not going to work with them that much in the course. We're going to work with slices all the time. And because I'm really thinking about an array data structure, a collection of variables that are lumped together, I may use the term array. And if I do, in Go, we'll still think of this as a slice. It's certainly a quirk of Go, but it's one that is not actually too hard to get used to think about slices as being what we really mean when we talk about arrays. A couple more things I wanted to discuss. One is, let's do a little bit of practice. So why don't you try to write a function called min integer array. And this is, again, I'm going to practice exactly what I was saying, which is I really mean a slice, but I'm going to call this function min integer array. It's going to take as input a slice of integers and returns the minimum value in that slice. So over all the variables that are in that slice, it could have 2 values in it, it could have 100 variables in it. Over all of them, regardless of how long the input slice is, we want to return the minimum value. And I'll let you practice this if you like. I can say func min integer array. It's going to take a slice of integers as inputs, and it's going to return an integer. Give that a go if you like. I'm going to show the function, but I think you know well enough to think about how this function might work. So give it a shot, and then I'm going to go ahead and write it. The first thing that I might do, of course, is to check and say, well, is it the case that there's nobody home? So is the length of the list equal to 0? And if so, I don't want to start accessing elements because there are no elements. And if that's the case, we probably should panic. Empty slice given to min integer array. Okay. If I make it here, then I know I'm in good shape. I know I can start accessing values of the slice. One way I might write this is to say, well, let's declare a variable m that's going to store our minimum, and I can set it equal to, say, 0, or var m int, just declare m. Eventually, that's what we're going to return. And I'll say will store the minimum value. And then we want to range over the list, and if we find something that's smaller than m, update m. So I could say for I colon equal to 0, I less than length of list, I plus plus. That is a very standard way of writing a for loop to range over values of an array or a slice. Because we know, what did I tell you? That the indices start at 0, and they go up to, but not including, the length of the array or the slice. So they go from 0 up to the length minus 1. You will appreciate in time that I like writing it as less than length of list. I will explain sort of more about indexing in a later chapter. But for now, I'm going to point out it doesn't matter which of those you prefer. And in fact, I'm going to use an even better approach for indexing a for loop for ranging over an array. But for now, let's say for I colon equal to 0, up to the length of the list, but not including it, increasing I by 1 each time. Again, when we find something smaller than m, so by something smaller than m, I mean list of I. So if list of I, the current value that I'm considering in my array, is less than m, well then let's update m to be list of I. So that will take me over the entire array slice, and when we find something that's smaller than the current value of m, I'll update m accordingly. And then eventually at the end of this for loop, I'm going to return m. That looks great. It suffers from a bug. There's a bug in this function. It's not a compiler error or anything, so I'll prove that to you, I hope. It compiles. But there is a problem with this function, and it will run, but it just doesn't work on certain inputs. I'll give you a hint on that. If you want to pause and think about it, go for it. The bug that this has is I want you to imagine what happens if, for example, every value in the list that I give as input is positive. So think about a simple case. It's always good to think about simple cases. A simple case like we give it a list that's where it has 3 values, and the three variables have values 3, 2, and 1. If that's the case, then we set m equal to 0, and m has the default value. And when we range over the list, we'll actually never find something that's smaller than m. So we declared m to be equal to 0 up here, the default value. And so if everybody in the list is positive, we're never going to update m. And so we would return 0, and that would be wrong. So that's a minor issue for some types of slices, although that's a pretty major issue if you're working with data where everything's positive. And so you might imagine, well, how is it we can get around this? One way that we can get around it is to set, instead of var mn, instead of declaring it equal to some value that we don't need it to have, set it equal to the first element, the 0th element of the list. And then if everybody in the list is positive, well, we may never beat this, but we're going to return m. So that would fix that issue. For example, consider the list 1, 2, 3, those being our values. Then m would be equal to 1, and nothing would ever be smaller than 1, but we would return 1. So that's good. One more thing, though, is that we could make that a little bit more efficient by starting our ranging at I equal to 1. So at an index equal to 1, because we've already set m to be the 0th element of our list. That's fine, and this function will work. It will resolve the bug. I'm not going to go and call it on different things. I'd rather talk about a different way of writing this function. So, as we go through the course, we're going to start to see, I think, that there's quite a few different ways of getting at things. And even for a task like this, which is take the minimum value in an array, there's going to be a different way of doing it. You might want to pause and think about what that might be. The way I'm going to do it is to say, well, actually, we could have declared, what am I doing? We could have declared this as var mint. It could have had a value of 0, but we need to make sure that if we're at the initial element of the list, then we set m to be that initial element of the list. And maybe we could handle that within the for loop. So we could range starting at 0 up to the length of list. And we could have, this is a way of practicing our logical connectives. So we could say if I is equal to 0, meaning if we're at the first element of the list, or if the current value of the list of I is smaller than m, in either of those cases, we're going to update m to be list of I. So I will say if we are at the 0th element, or we find something smaller than m, then we're going to update the value of m. I like that a little bit better because I like having kind of one for loop, although there's absolutely nothing wrong too with setting m equal to the initial value up here, but I like ranging over everybody in the list. It makes everything nice and consistent. Just a matter of preference. I like that in particular because I want to show you two things that are shorthand tricks when we range over elements of an array or a slice, or we're going to work with maps soon, and this is going to apply to those too. If we're ranging over every element of a list, well, that's a very common thing to do, and so a lot of languages have a way for us to just quickly say, I want to grab every element in a list, starting with 0 up to the final one. And the way that Go handles that is to say, let's replace all of these three statements with the keyword range. So if you have I colon equal to range of list, this is equivalent, Go will convert it behind the scenes, to for I colon equal to 0, I less than length of list, I plus plus. So part of why I like this way of writing the function better is that it allows me to use this keyword range and simply range over everyone in the list. The other shorthand I wanted to show you is you can, when you apply this ranging of over everything in an array or slice, you can also get the values. So you can get not just the indices of the array or slice, but you can get the values too by adding, after a comma, some variable name that's going to represent the current value that you're considering. So as you're ranging through, you're going to get the index I, but you're also going to get, so that you don't have to type out list of I every time, you're also going to get the current value corresponding to list of I. So I can replace list of I here with val. And it might, just as a final aside here, it might be the case that you don't actually need I. In this case, we do. But if you're just interested in the values of an array or slice, you can get rid of this index entirely and just replace it with underscore. That would tell Go, I don't care about the index of the array. I just want to range over the array or slice and grab the values. In this particular case, I do care because I need to have that check of I equal to 0. One more topic that I want to present today is the subject of variadic functions. So we have worked in this course, we've started to see functions, or one of the first functions we worked with when we talked about conditionals was a function min2 that takes two integers and then it returns the minimum of those two integers. And we, in the main text at least, talked about, well, you could write a min3 function and use min2 as a subroutine. And how could we then write a min4 function that takes 4 integer inputs and returns the minimum? It would be very weird if every time we wanted to have, plug in a collection of variables into a function that we had to write a new function just to take the minimum. So Go understands this, as do other languages. And the solution is to have what's called a variadic function. So what is a variadic function? A variadic function is something that takes a variable number of inputs. Right now, if you tried to pass 2 slices in a min integer array, what's going to happen? A compiler error, and that's good. But sometimes we want to allow ourselves to pass in a variable number of inputs into a function, like if I want to have a min function that can take an arbitrary number of integers and just simply take the minimum. So we need to know, I need to present to you how it is that we represent a variadic function syntactically. Here is the function that we want. So min in integers is what I'm going to call it. And it's going to take as input an arbitrary number of integers, and it's going to return their minimum. So I'm going to have a min integers function. And to indicate to go, I want to pass in an arbitrary collection of integers. I'm going to call those integers whatever I like. In this case, I'm going to call them numbers. And to indicate that there can be more than one of them, I'm going to have an ellipsis, ... followed by the type. In this case, it's int. And I'm going to return a single integer value. Now you might wonder, okay, this means I can pass in however many integers that I like. What is it that's going to happen here in terms of the function? And when I highlight it, you actually can see it pop up. The variable type here is a slice of integers. So Go will create a slice called numbers for you behind the scenes. So if I plug in 3, 6, 7, 1 into my min integers function, Go is going to create a slice called, in this case, numbers, that's going to have 4 values, 3, 6, 7, and 1. And so in order to write the body of this function, it's going to proceed in the exact same way. I will have basically all of this code here, and the only difference is that instead of list, it's going to be length of numbers. And I'm just going to replace everywhere I see the word list with the word numbers. I just committed somewhat of a sin, though, and which is that I copied and pasted code from one function into another. And what I try to teach my own students is that if you're ever copy pasting code from one place in your code to another, there should be like a giant siren, alert siren going off in your head that this is an opportunity to have one of the functions call the other or to have a subroutine. And because if you have buggy code, for example, you just duplicated buggy code and put it in more than one place. Plus, there's probably a way of writing this in a more efficient manner, and that is certainly the case here. So I want to still keep my panic statement, but if I survive the panic statement, then a quicker way of doing this is to say, wait, numbers, whatever I passed in here, that became a slice. I already have a function that takes a slice of integers as input and returns their minimum. I can just get rid of all of this and return min integer array of numbers. I've got too many parentheses again, but otherwise, this is a nice little shortcut way of doing it. So I really only have one function that I need to test or debug, which is this min integer array function. And then min integers is going to be a variadic function that just relies on this function that I already wrote. So that will make things nice and concise. And I'll just show you before finishing up. Let's call this function on some values. I'm trying to remember what values that I told you. I think it was 3, 6, 7, and 1. Who knows? Okay. So I've given it 4 values here, and when I compile and run, I should see 1 get printed. Yeah. If I want to add another value, 5, I still see 1 printed, and it was okay that I passed in multiple things. And if I want to add -43 in there and compile and run, it prints -43. So however many arguments that I want to pass into min integers, I now just have one function to handle this case. That's it for this code along. We're now that we've learned a bit more about arrays and slices in Go, we're ready to apply what we've learned to implement some prime finding functions. So that's going to be the thrilling conclusion of this chapter, and that's what we're going to cover in the next code along. So I hope you'll join me, and I hope you had a good time. I know I did. And I'll see you next time. Happy coding.